So we just talked about how we could shift a graph vertically. Now what would I want to do if I wanted to shift it horizontally? So let's say, for example, I had f of x equals x, that's our identity function, and I wanted to shift it to the left 3. So I want to take my x-intercept and I want to move it 1, 2, 3. I want to take every point on my graph and move it over 3. Well, that would change my y-intercept, right? My y-intercept is now a positive 3. So this function would become f of x equals x plus 3. We had to change our x value, right? That's the same thing as shifting it to the left. We could also do the same thing if we wanted to shift it to the right. That'd be f of x equals x minus 4. Even though we're shifting in the positive direction, it becomes minus 4, because as you can see, our y-intercept is shifted down to negative 4. So when we're shifting it vertically, we add directly to our function, which is y, right? Y equals f of x. And when we're shifting horizontally, we add to our argument. That's what we call our x squared. And this works for all functions. So let's take a look. So for horizontal shift, if I have a real number h and it is added to the argument x of our function, it's shifted left h units. So y equals f of x plus h. If a real number h is subtracted from our argument, it's actually shifted right, so in the positive direction. Now, it's important to note that I know this feels opposite, but let's look at some examples, and I hope that'll clear things up. So let's describe the following shift. I have y equals x minus 2 squared. So let's take a look at our parent function. By parent function, I mean like our original function. This is y equals x squared. We know this is going to look like a parabola. So let's go ahead and find a few points on this function. Now I know this is going to be shifted to the right 2. So every single point is going to move over 2. But what if I wasn't confident about graphing this? Or what if there was other factors involved? We'd need to find a few points to verify that this was true. This point right here, where our parabola changes from looking like it has negative slope, which is decreasing, to looking like it's increasing, is called the vertex. And the vertex, through the vertex, is where we have our vertical line of symmetry. So let's go ahead and look at some points. So I'm going to take a look at when x is 1, 2, and 3. This is our x coordinate for our vertex. We know that these two are going to have the same value because it's symmetrical. So I have 1 minus 2 squared. That gives me negative 1 squared, which is 1. I have 2 minus 2 squared, which gives me 0. And I have 3 minus 2 squared, which gives me 1. These are my points. I've got when x is 1, y is 1. When x is 2, y is 0. And when x is 3, y is 1. So in this example, we have y equals the square root of x plus 3. So its parent function is a radical function. Let's sketch our most basic radical function. So when x is 0, y is 0. Square root of 1 is 1. Square root of 4 is 2. So here's our most basic radical function. Now this graph is shifted. This graph is shifted left 3. So even though I'm adding, I'm shifting in the negative direction. So we're going to graph that in orange. I'm going to move over 1, 2, 3. Every point, move it over to the left 3. And there we have our beautiful shifted graph. So let's double check that that's the case. I'm going to do that by checking my newly found x values. When x is 1, negative 3. When x is negative 2. And when x is 1. So the square root of negative 3 plus 3 is 0. The square root of negative 2 plus 3 is 1, and the square root of 1 plus 3, well, that's the square root of 4, which is 2. So we did shift this graph correctly. So you can always find points on your graph if you aren't sure, if you remember exactly how to shift your graph, or if you want to check that you drew your function correctly.